So now we have more of these algebra tiles, but we're going to do these now with the more complicated type that we've been doing. I want to review a little bit of what we, the factoring tree we're developing of what to do. Number one, always look for a greatest common factor. Number two, you look to see if it's two-term or if it's three-term, binomial or trinomial. And we're right now in the three-term factoring. We're looking at trinomials and what to do there. So that's what this is doing. Okay, so if we expand on this, we kind of look. Remember that with algebra tiles we have digits 0 through 9. And once again, I challenge you to pause this to see if you can do this on your own. It'd go a lot quicker. You don't have to listen to my voice. Okay, number one. We're now looking at the leading coefficient. I know that 7 times 2 is 14, and that works. So I'm trying to see what times 3 for my first would give me this 1 times something. Well, if I think about my possibilities, 3 times 3 is 9, 4 times 3, 5 times 3, and 6 times 3 would work. Then I look to see what's going on with my middle term. I have, let's see, that would be negative 21 minus 2 times something. Well, if I think about this, negative 21 minus 2 times something, and that's going to give me something that's in the 20s. That means that that 2 times something would have to be 2 times 4, because if it were 2 times 5, it'd be negative 31. 2 times 4 gives me negative 29, which means that if that's negative 29, that can be a negative 29. 2 times 4x, and that would mean 4x times 3x is 12x. So I've already knocked off the 12, the 9, and the 4, and I'm pretty confident that those are the only possibilities there. Okay, moving right along. I'm going to take these down here. We have a trinomial equaling two binomials. So if I look to see what's going on here, I know that I have negative 13x as my middle term, and I know that negative 10x minus something would be equal to 13x. Well, that means that this has to be 1 and 3 or 3 and 1. Let's try 1 and 3. If it's 1 and 3, then my negative 5 times my negative 3 is going to be 15, which can't work because these are supposed to be digits. So let's switch this around and make this 3 and 1, which means that this would be positive 5. And then that means that 3x times 2x is 6x. So that just knocked off quite a few other ones. I've knocked off the 6, I've knocked off the 3, I've knocked off the 1, and I've knocked off the 5. So all I'm left with is a 1, 7, and 8. Okay, well, this now looks kind of obvious that this would have to be a 7 here, because 7 times 1 is 7. And that gives me the rest of it. First would be 8, and then 28 plus 2 is 30. Is that right? Oh yeah, we already used the 1. It was the 0 I needed. 0, 7, and 8. Okay, that works. Next page. Again, I'm going to write them all out at the top. 6 times what is 24? It's 6 times 4. That one has to be that. So that means outer and inner plus 12x plus 4 times, that would have to be a 5, because 5 times 4 is 20. 20 plus 12 is 32. And that makes my last become 10. So 0, 5, and 4 are out. Okay, next set. I have 16. Let's see what we can target. 8x times what is 16? That'd have to be a 2x. 8 times 2 is 16. What times 5 is 35? That has to be 7. So that knocks off the 7 and the 2 pretty quickly. And then if I figure out what my middle term is, that's the outer is positive 10 and the inner is negative 56. So that'd have to be positive or minus 46 here. So that gets rid of the 6. And finally the 1, 3, and the 8 can come down to the next one. And we'll figure out where those go. Let's see. This is 2 times a box is equal to something 6. That has to be 2 times 8 to give me 16. I had another digit, but oh well. doing bad erasing these digits. Okay, then 7 times what? I want to do 7 times, let's see, 7 times something to give me 60 something. That has to be 7 times 9 would give me 63, and let me just make sure I didn't use the 9 somewhere else. Nope, I didn't. I just accidentally erased it. Okay. Yeah, 7 times 9 is 63, and then let's just check. First outer, negative 18. Inner is positive 56. 56 minus 18 is 38, so that works. Okay. I'm going to try not to erase too many digits here this time. We want something times 2x to equal 12x. That would have to be 6x. Then we can just FOIL the rest of this. First, outer, 30. Inner is 2. 30 minus 2 is 28. And last is negative 5. So 6, 8, and 5 are out. Let's carry these down. Then I have 28, 31, 7. And it looks like I'm supposed to multiply two things to get to 28. That should be 7 and 4. So let's try writing it. There looks to be a lot of stuff going on here. Let's just write this as 7 and 4 like that and see what we can come up with. If I go inner, that'd be 56, and last is 4 times something. Furthermore, I want 8 times something to be equal to 70 something. Well, that'd have to be 8 times 9 to give me 72. So now I just have to check to see if I can have this to get to 31 correctly. 8 times 7 is 56. 9 times 4 is 36. And if I subtract those, I don't get to 31. So let's try switching the 7 and the 4 to become a 4, or just switch places. Okay, now I get 84, or sorry, 8 times 4 is 32. And 9 times 7 is 63. And 63 minus 32 is 31, so that works. My outer and my inner check now, and give me the middle term. And then my last, 8 times 7 was 72. We knew that from before. So I get rid of the 7, the 9, the 2, and the 4, leaving me with the 0, 1, and 3 for the last set. And seeing the last set, I have 2 times 5 is 10. Then my outer is negative 8. Let's see, I already used the 1. So I should use a 1 here to get 1 times negative 4 is negative. And let's just check that this would be the 3 that's left over. My outer is negative 8. My inner is positive 5. And that should give me negative 3. So that all checks out. Okay, one more set. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 times 1 is 5. Check. I have a box times a box equaling 40 something. That's no help. You know what? Let's maybe take these down here, because there seem to be a lot of blanks here that really aren't helping me figure out what I need to get to. I have 5 times something plus something times x equaling 33. That's just too much stuff going on. But if I look here, I can start to eliminate stuff. 2x and 3x give me 6x squared. That works well. I know that 9 times 2 is 18. And then I have 27 minus 4 giving me 23. So 2, the 3, and the 6 are out. Okay, we're eliminating possibilities all over the place. Let's just keep bringing these down, and maybe we'll come back up to the top in a sec. Okay. Here I have 3 times something is equal to 20 something. And I have something times x is equal to 4x. Okay, so this has to be a 4. And that means that, let's see, first is 4. Then I have 12 plus another something times x. And then I have to get 3 times something equaling 20 something. So this thing could be either a 7, an 8, or a 9. Kind of looking at how it works, because I know 3 times that would equal 20 something. So let's look at the outer. The outer is a 12, and the inner is a, well, if the outer is a 12, the inner would have to be 7x, because if it was an 8x or a 9x, it would be a 20-something for that middle term, not a teen. So this has to be 12 plus 7 to give me 19, and to give that 21. So kill the 7, kill the 1, and now we have 0, 5, 8, and 9. So let's go back up to the top with 0, 5, 8, and 9. I know that 9 times 5 is 45, but that's not going to help because I have 5 times something, so I also want to get a 0. Let's start looking at what my possibilities are for this. We can do a little guess and check. We say, let's see, I can't do 0 here or on any of these. Neither of these could be 0. I've got one more that I'm done. Oh, I can't use a 9. 0, 5, and 8. So this would have to be a 0 since the other ones can't be 0. So really I'm down to 5 and 8. Well, 8 times 5 is 40, and then, let's see, if we do 8 times 5 and 5, that won't work because we have 40 and 5, and that will give me 33. But if I have 5 times 8 is 40. If I do that, that's minus 25, minus 8, it's minus 33. And that's it.